I think we did it. So we have what we call the effect. The effect of solubility. The effect of temperature. The effect of temperature on what you call solubility. The effect of temperature on the solubility of what you call potassium nitrate. And therefore, we'll be looking at what is the effect of the temperature on the solubility, specifically for potassium nitrate. Now, we have the table that I will have to fill and then draw the graph. So we have the temperature in degrees Celsius, and then we have the solubility of potassium nitrate. Therefore, we have this table here, Now, we start at the temperature at 0 degrees Celsius. We say that the solubility, it is 20, the solubility of potassium nitrate. And then when the temperature is 20, we say that the solubility is 40. And when the temperature is 40 here, we say that the solubility is 60. And then when the temperature is 60 here, the solubility is 80. And then when the temperature is, I think that was the last one. That's the last one. Now, if you look, I want you to look at this table and tell me what you can conclude. What is the relationship between the temperature and the solubility? The temperature is from 0 to 60. And therefore the solubility is 20 to 80. What can be the conclusion in terms of the relationship between the temperature and the solubility based on this table? What can you conclude? Yes, Jack.
When temperature increases, the solubility also increases.
When the temperature increases, the solubility increases. So we are saying that an increase in the temperature increases what we call the solubility. Now, after that, you use this table to draw a graph. And then use the graph to answer some questions. Now, I want us to now use this table. I know you have drawn. Now, I want us to use it now to draw the graph for the solubility. I told you how to draw the graph. So I will only sketch here. And therefore, you will draw it in your graph paper. Now, we have this. And then we have this. So we say that this one is the temperature. This one is the temperature, which is in degrees Celsius. And then we have, this one is for the solubility, which is in grams. 100 grams of what? Of water. The solubility, which is in 100 grams of water. So we say that this one will be 0. 0. And therefore we say that from 0 we go to 20, 20 to 40, then 40 to 60, then 60 to what? To 80, 80 can be to 100. Then the same happens here. This one is 20, then this one is 40, then this one is 60, then this one is 80, then this one is 100. And then now you plot the graph. And therefore we say that when the temperature is 0, the solubility, the first one was 20. So you come here and say that this one is my 0. And then from here, I say that my solubility here, it is 20. So I cross at 20. Then the next one is, when the temperature is 20, the solubility is 40. So you say that my 20 is here, so the solubility is 40. So you will bring it here. That is where I have my solubility. Now, if the temperature is 40, the solubility is 60. So 40 is here, my solubility is 60. So I will put it here. And then the next one, when the solubility is 60, the temperature is 60, the solubility is 80. So it is here. The solubility should be 80. Somewhere there. And then the next one, when it is at 80, the temperature, the solubility, if it is here, so the solubility is also, the solubility is what? It is 100. Eh? It is 100. Or you can put it there. That is 100. Now, from this, you can now plot. You can now plot your graph. You start from the first point. You don't start from the last point. So our first point was here. You don't use a ruler, isn't it? Use a free hand. And therefore, you come and say that I'll have this, I'll have this, I'll have this, then I'll have this. So you ensure that your line does not twist, because it's not supposed to be a zigzag. So wale wanakunywa mnazi wapata tabu. So this one is your curve. And I said that when you are drawing what you call the solubility curve, if you don't draw anything like this one, then know that you are wrong. This one is the shape for the solubility. So if you draw anything that does not look like this, then you are drawing your own thing. Now, how do we now answer questions from this graph? So for example, they can ask you that to calculate the mass or the solubility of the solid form when the saturated solution was cooled from 70 degrees Celsius to 40 degrees Celsius. They ask that, can you calculate what you call the mass of the salt that was formed if the temperature was cooled from 70 to 40? So how do you get the mass of the solid that crystallized from the solution when it was being cooled from 70 to 40? But the issue is that they're asking you to use the graph. So you use the graph. But how will I confirm that you used the graph? So what you need to do is, number one, to get the solubility at 70 degrees Celsius using the graph. And then also get the solubility at 40 degrees Celsius. So how do you get? You come here and say that you go back to your graph and check where there is 70 degrees Celsius. So we have 60 and we have 80. So mean that 70 is in between the two. But if you are using your graph, you can be able, depending on the scale that you used, you can easily identify where there is 70. And therefore say that 70 is here. So you will take your your ruler. You will take your ruler. Give me that ruler. You will take your ruler. Weke hapa. I'm very sure that if it is in your book, ukiweka hiyo ruler itaenda mpaka where there is the car. So take a ruler and then you will join using dots up to where there is that car. And then again you put the ruler this side and then make again up to this side. So the value that they want you to get is the solubility that is here. But now you must show me that you are using the graph to get the solubility at 70. So when I'm marking, I will not come and mark here, but I'll go back to your curve, because remember the question is that using the graph. So you must show me that this is how you got the solubility. So if you read here, we can say that maybe it is something like, let me say, it is something like 81. That's the solubility. Now we go to 40, you do the same. So 40 is here. So we say that at 40, you will again put the ruler, join it, and then join it. So we'll say that here, the solubility is 60. So for you to calculate now, you get the difference. So you will get 81 minus 60, which will give you what? Something like, what is it? 21, which is grams per 100 grams of what? Of water. So that one will be the solubility using what you call the graph. And then from there now, they can twist the question. They can ask you now, can you identify what you call the temperature at? The temperature at, let me say, 30 grams per 100 grams of water. So they want you now to identify the temperature. So meaning that you will come to your car, identify where there is that gram of the solubility. I'm assuming that it is in between here. That is where my solubility is. Then again you put the ruler up, put the ruler here, ensure that it is straight, and then unaweka dot. Then again you do the same. Unakuja unaiweka hapa, and then you do the same. And then you read the temperature here. The temperature that is here is what they want you to write there. And therefore, we say that when you are drawing the graph, we ensure that it is covering like more than a half of your graph paper. More than a half of your graph paper. And for you to do that, you get the right scale. You can write the heading if you want. It does not have the mark, but you can write if you want. Ensure that these arrows, don't forget, you must have it in your graph. Now, so that is generally the question that they will ask you to calculate when it comes to the issues of the solubility. I think that one is enough. Is enough. Assignment. I want you to open on page 27 of your textbook. Page 27. Page 27. Page 27. Are we there? The amount of sulfur oxide that can dissolve in water at different temperatures is shown in the table below. The temperature is there, solubility of sulfur oxide in grams of water. At 5 it is 190, at 10 it is 154, up to when the temperature is 56. So the question is, A, plot a graph of the mass of sulfur oxide gas, the sulfur oxide against the temperature. I think that one you can do, isn't it? And then they say that the mass of the sulfur oxide that will dissolve in 1 liter of the solution at 20 degrees Celsius. I think that one you can do, isn't it? So you go to at 20 degrees Celsius, use a ruler, identify the solubility. And then they say that the temperature at which a liter of the solution containing 40 grams of the sulfur oxide, from the graph, and you see the question is that from the graph, you determine the temperature at which, you can see now, the other one was the mass. Now they want you to identify the temperature. And therefore, the last one is that calculate the molarity of the solution at 50 degrees Celsius. So they want you to calculate the molarity at 50 degrees Celsius. And we know very well, if you want to get the molarity it is the number of moles but in 1 liter. So what you will do, you will go and using your graph, identify the mass at 50. You identify the mass at 50. What you get, it is in 100 grams of water. So you will convert it to 1,000. Melana. Now once you convert it to 1,000, then you say that mass divided by what? The molar mass of sulfur oxide. And we have been given sulfur is 32, oxygen is 16. So you get the what? The molarity. Is that okay? So can you do that assignment? You can get the graph. If you don't have the graph, I can give you one. Then you draw that one. I want to do it now so that I can mark. So the sound. You have the graph paper. You have the graph paper.